So good morning to this live meeting regarding Ntop technologies and how in the ecosystem of NetEye we are using them. Here is Georg Kostner speaking from wuerth-phoenix. I'm responsible for NetEye and the business unit. And I'm glad to be that Luca and Alfredo from Ntop itself is joining us during this meeting on presenting to us the technologies of Ntop itself, how they can be used to create a deeper visibility in our networks and help us to understand what is going on in our networks from the throughput latency point of view, but also from security and cybersecurity point of view. I will give you a short, briefly introduction to this topic from the NetEye point of view. So with NetEye, we are addressing an ecosystem in the monitoring, visibility, and observability view, to create a unified or to propose a unified monitoring approach. And as I said before, in this webinar, we are talking about network monitoring and network visibility. I will be short in this introduction so that Luca and Alfredo have enough time to show you all the details of the Ntop technologies. Ntop itself, or Ntop ng from with the version 4, which is then released in 2020, we started to integrate the collector inside NetEye itself. So you can enjoy to use ntopng directly in NetEye using the ntopng subscription. The technology will be deployed on the NetEye appliances in combination with nprobe, which is responsible to get the NetFlow collections. So let me introduce in a few words the use cases, how we can gather the network information from the network layer. So there are two mainly use cases. One is to let Ntop technology inside the Nbox appliances, which we propose in our project to analyze the traffic on the wire directly. To bring those traffic to the Nbox, we have two ways. One is to use the port mirror span port approach on network devices, mainly on switches, or to use passive network taps to mirror the traffic in a fail-safe way from a physical point of view to the Nbox. With this approach, nprobe on the Nbox itself is analyzing the traffic and show the result on ntopng directly on the Nbox itself, or how it's shown here on this diagram. Via CMQ can be sent these details on ntopng, which resides inside NetEye itself. In the NetEye ecosystem itself, then this information can be future analyzed with, for example, the ecosystem of Elasticsearch, which we have inside NetEye, for example, in CM, and all the alarms which ntopng is raising through different analysis can be shown directly in the Ising web overview to let flow all this information through the NetEye system and optimize the work with it. Another approach, or the combination which can work, is the Nbox, which analyze the traffic, can ship this data using the NetFlow protocol or epfix to another Nbox. So if you have more network segments to analyze, you can deploy more different Nboxes and ship the NetFlow data to a collector, ntopng inside the Nbox itself, or to gather the NetFlow from the network devices directly. Or another option could be an Elasticsearch cluster, which is able to get this data, or there are other NetFlow collectors on the market. The second use case is not to analyze the network links on the wire with nprobe directly, but to ship or to do this job on network switches. There are different protocols: NetFlow, epfix, sflow, jflow, and different vendors which now supports the analysis on the devices itself, and they can export this information to send these data to Ntop. In NetEye, Ntop is responsible to receive this flow and integrate information in ntopng, and the same approach can work on our Nbox directly. So we came to these deployment scenarios. So if you will have a full unified monitoring approach, you can go with NetEye and activate the ntopng Nprobe subscription and to get all this information inside NetEye on the physical or virtual appliances. Or you can use Nbox appliances to do this job from a network visibility point of view. In addition, the Nboxes have also the end-to-disk technology from Ntop, which is able to capture the traffic and write pickup files to analyze those pickup files future with Wireshark and to go deeper in this kind of analysis. Or the second option is to use the flow export capabilities of the network devices directly. So this is all from my side for this short introduction on how the use cases and the deployment during projects are organized and the option we can deliver to you to get the benefits about the Ntop and technology. And I will pass over to Luca and Alfredo now so that they will tell us in more details and deeper what is possible to do with their technology. So Luca, you can start.
Yes. Okay. Good morning. My name is Luca Deri, and I am a colleague of Alfredo. We work for Ntop, and the idea is that today we'll be talking about how Ntop allows us to monitor the traffic during this lockdown days, because the problem is that the traffic has changed quite a bit during this time, and in essence, the traffic is a little bit different from what it used to be in the past. Can you see my screen today?
Yes. Yes.
Okay. So with my colleague Alfredo, we'll be giving you a short introduction to what ntopng is doing. We'll be talking about the impact on the infrastructure of the lockdown. So in essence, how the system, the lockdown changed the system availability, usage, and access. And we'll show you how our tools can benefit from this lockdown, because it can allow you to see what is happening and can show you what users are doing. So in essence, the change in infrastructure due to the change in working condition is affected, of course, but the visibility and the ability of producing alerts and generating net flow data is not different. So in essence, you have the same visibility as you used to have, while remote workers are doing their job from a remote location through VPN. And the last part of the talk will be about the integration of our tools with user visibility. In the past, NetFlow and SFlow were the most interesting sources of data, sources of information. But with the remote users that are talking with central systems from remote, it is important also to talk with different type of devices, such as VPN concentrator, for instance. And also it is important to understand if remote users are somehow affecting the network with security issues, because a remote user is not longer under the control of the network administrator, at least it's partially under its control. And then this is an important point to take into account, in particular when many users are connecting from remote and therefore are using the infrastructure in a way that is different from what it used to be in the past. Let's start with a quick introduction to our tool that, as Georg said, it is part of NetEye. And so you can talk with Georg for NetEye integration details. I will now focus just on the tool, just to give you an idea of what the tool is able to do. In essence, we are doing real-time visibility and network monitoring. So it means that you will see a dashboard like this that is full HTML5 compliant. So therefore, you can click anywhere, and then you will be able to explore the data, and you will be able to see, for instance, what hosts are doing what type of communications are flowing in your network, only in real time.
Sorry, Luca, I can still see the title, the first slide, but I don't see.
So it's not moving because
I think it's
nothing happens. Do you want to show the slide then? I don't know. My screen is.
Yeah, sure. Yeah. Now I can see the slide.
Okay, so probably better like this. Okay, so in essence, with ntopng, we are able to see in real time what is happening on the system, and this in real time. So it means that we are able to understand without any kind of delay the changed conditions. So, for instance, if somebody is doing a file transfer, you will immediately see the file transfer happening without having to wait for a few minutes, as it happens with NetFlow because of the delay in the protocol. And ntopng is able to collect flows. As Georg said, we have spent quite some time in version 4 to optimize the performance. We are able to handle about 100,000 flows per second per interface. And inside ntopng, we're able to define multiple collector interfaces. So it means that you can scale up as much as you want, limited by the resources of the system. At the same time, we are able to do packet processing. So you can mix network interfaces that are able to process packets with NetFlow data collection, all in the same place. And you can have a unified visibility console so that your network is monitored regardless of the type of the protocol or the source of data sent to it. Of course, we are able to store data for a long time. Usually, this can be done with third-party databases. So many people are using Elasticsearch, for instance. So ntopng is able to store directly into Elasticsearch the data, so that Elasticsearch becomes, in essence, a database, and then you can explore the data either through ntopng itself or through the tools of Elastic. At the same time, we're able to store network metrics into a time series database. At the moment, we support the round-robin database and InfluxDB. And in particular, InfluxDB, it is interesting because it is possible to access the data with other tools such as Grafana, or using the InfluxDB itself monitoring capabilities. So it means that you can create your own dashboard, and that ntopng can become a source of data, a source of information that allows you to correlate the data and to provide information in a way so that people can immediately interpret it without having to pay attention to the integration of various sources of data, or later, like Alfredo will show you, about the user identities, because ntopng is doing that. And of course, it is possible to do integration with the CM. Elastic has CM capabilities, but I will show you that there are other possible options for that. And also that there are some security applications such as Suricata that are being integrated for providing more information in this respect. Talking about using data source and using Ntop as a data source, so that you forget, in essence, the user interface. You use it as a way to collect data, aggregate data, and egress data to a database. This is an example of Kibana being used to create a monitoring console on top of ntopng. You will see that inside NetEye, you have the ability of accessing this type of data. So in this case, with Kibana, you can monitor traffic, in particular network metrics stored into Influx. But there is also the companion tool that allows you to monitor data and access data directly stored into Elastic. So in essence, we can configure ntopng to store data into Elastic, and from Elastic you can create your own dashboard. You can generate your own alerts and everything you're able to do with Elastic. In general, today people prefer to monitor as much as possible using the network. However, sometimes it is necessary to install agents for improved visibility on remote systems. So, for instance, we have developed a tool called ntopng agent that is a complement to ntopng and ntopng installation described by Georg before, that can be installed on selected systems to provide further visibility. So, for instance, with ntopng, looking at network packets, we can see the traffic, but we cannot know the application that has generated a certain type of traffic or the user that has used the application that generated that traffic. With ntopng agent, it is possible to do that. And it is not required to have the ntopng agent everywhere, but we can have the ntopng agent only on selected systems. Of course, on the system, you will have a full visibility. On another system where the agent is not present, you will have network visibility. But this is possible. And as shown in the picture, you will see that ntopng can save data simultaneously into Influx, into Elastic, and it's possible to use those databases to merge data. So, for instance, many people are using Wazoo as another type of data source, and you can put everything into the same database for doing correlation. And wuerth-phoenix is also using that database, so you can create an aggregated view using many sources of data in a more comprehensive way with respect to what the network and what ntopng is able to provide you. The last few words are about cybersecurity. In the past months, so we have introduced the ability of integrated IDSs into ntopng, and this is an important add-on because it allows us to complement our network visibility with information coming from other type of data sources. In this case, it's Suricata, that is a signature-based IDS. So this means that the alerts generated by ntopng can be richer, and that the alerts that can be as well exported into Elastic, and that you can do a better correlation, not just looking at the traffic behavior, but also at the pattern of the traffic that are being recognized by the signatures. And by default, all our tools recognize weakness of protocols such as insecure ciphers or old versions. And this is very important because many times when you have an attack or when you have an infrastructure that is somehow insecure because some machines have obsoleted versions of protocols, it is important to pinpoint where they are located and to find a solution to this problem, doing either an upgrade or putting those devices in a separate part of the network, a separate VLAN, so that they are not affected by security issues. Now, after this short introduction, let's go to the main topic of our webinar today. So, in essence, the lockdown has been, a big problem for humans, but it has also been a big challenge for people that have to administer the network, and for those who are doing remote working that didn't do that in the past, because the infrastructure had to be updated and reconfigured very quickly, and also because the traffic flows that we used to observe in a network are not the same. In practice, this change is not temporary, but for many companies will be permanent, at least for a part of the workforce. So it means that we have to deal with this new changed environment, and we have to be able to monitor and to understand the implication of the change. And the problem is that in the past, when people used to all work in a site, the communication were mostly local, whereas with the lockdown and remote connections, in essence, delays and new type of devices like a VPN concentrator that used to be used only temporarily when people were out of the company are now used permanently. And we need to understand, in particular, as network administrators, what type of user experience, what type of metrics, network metrics are observed by the users, so that they're not affected by this change. Before the lockdown, in essence, it was somehow straightforward network monitoring, because you can put your device in the network. Probably a nice location will be close to the network gateway, and through NetFlow or SFlow, if you want to monitor also the internal network, you can collect the traffic and you can report this to the central monitoring console, such as ntopng, and see what is happening. The thing is that today most users are remote and they connect in a different fashion. So the PC is not longer attached directly to the network. There is no DHCP or local traffic whatsoever, but everything is happening remotely. So we had to somehow update the visibility, because in post-lockdown, you will see that people staying home will be permanently connected to the company. And some traffic will go through the company network, other traffic will go to the cloud. So for instance, today with Teams, we are not sending our traffic from remote to the company and the company to Teams, but we go directly to Microsoft Teams from our private connection, so home connection or mobile. So it means that not all traffic is observed by the monitoring capabilities offered by a company. And this, in a way, it's a good thing, because all the traffic doesn't have necessarily to pass through the company, but it's bad because we are missing some data that we used to have in the past. So in essence, we have two problems here. So first of all, traffic patterns are a little bit different, and I will show you in a second what that means, how it affects the connectivity. And two, we need to bind users to traffic, because like I've said, broadcast protocols such as DHCP or MDNS are no longer present, because users are remote. And whenever we need to bind an IP address to a user, this is becoming a little bit more difficult unless we change our way of doing that. And also, I will show you now that the traffic is creating and is putting pressure on the network infrastructure of the company, because the new traffic patterns are a little bit different than what they used to be and how the infrastructure was designed. Now let's talk a little bit about the infrastructure. If we have to observe how video conferences, for instance, just to make an example, is affecting the network, the first thing to analyze is definitely the bandwidth. So we have done some experiments in the past few months using popular applications for video conferencing, such as Zoom, WebEx, Teams, as we're using today, Skype, or Google Meet. And in essence, the data that we see is that it is very convenient to use those tools. Instead of using the cellular phone, the audio quality is usually better. And if you use them as audio only, so as a telephone replacement, the bandwidth used by those tools is somehow limited. These values are expressed in megabits per second, so almost nothing. The thing changes instead when we use video. And because of the video capabilities offered by modern systems, the thing is that people are used to it, okay? So they like to use it, and once they use it, they want to use it also for private reason or for business meetings where the physical presence is not possible. So therefore, looking at a remote person can help. And in this case, the traffic is affected by this change. So in multimedia, very much for two reasons. First of all, because in the past, when you used to be in a company, usually those meetings were happening from a meeting room. So therefore, let's say 5-10 people sitting in the same place, all connecting with a remote site and sharing the same screen, the same web camera, and the same, in essence, the same computer. Whereas here, you will see that this traffic from the same 10 people is 10 times as much, because everybody has its own private computer that is doing that. So if I have to look at the traffic, and I see audio plus video, So in essence, you have a minified representation of the person, and you will see in big screen the remote users or the one who is speaking. You will see that the traffic is moving from a few kilobytes to megabit. So, for instance, in case of Teams or Zoom, the two leading software, you will see that for a video call, we take about 2 megabit. And this is an important change with respect to the past, because, like I've said, you have to multiply this by the number of users that are no longer sitting in the same room. And also, you have to combine it with the fact that HD video is becoming popular, and people are moving to those numbers very quickly. You will see that there are some protocols that used to be efficient but are no longer efficient, such as Skype, that are using much more bandwidth, so basically double the bandwidth. And this is not good news. The things are changing a little bit if we do remote sharing, like I'm doing at the moment, because in essence, the image is still, and there is no moving pictures. So therefore, the only difference between this and audio is that the system, it is sending only the update concerning the part of the screen, the portion of the screen that is changing. Because in this case, the screen is not changing much unless I move the pointer, you will see that, for instance, the traffic that you will have with Zoom only with audio or audio plus, video sharing, so screen sharing, is more or less the same. It's acceptable. So as you can see from this graph, the problem is that people are becoming used to this type of technologies. They want to use it more and more, even in a pervasive way. So no longer for meetings that can happen a few times per week, but even for direct people communication. So therefore, the impact on the infrastructure can be very important in terms of megabit per second. So in essence, as long as people are using video sharing to share a screen, like I'm doing today, or for audio, everything is simple. But if people start to use the camera, the impact on the infrastructure is pretty high. And I will show you in a second why this. During lockdown, in essence, you will see that the remote user were connecting from home. So they were connecting to, let's say, to Microsoft for doing a Microsoft Teams. So in essence, this traffic was not flowing to the company, but it was sent directly to the internet with very limited, if traffic at all, access to the company infrastructure, probably for authentication or for a little bit more than that. But in essence, the communication was not happening through the company, but everything was direct to the internet. After lockdown, when you have some people working in a company and some people still working remotely, you will see that in essence, the infrastructure is affected, because those that are sitting at the company desk are somehow connecting to the internet, doing, let's say, in this case, Microsoft Teams from the company infrastructure. So you have to multiply those 2 megabits per second by the number of people that are doing that. And because, in particular, those protocols such as Teams or Google are becoming more and more pervasive, you will have Microsoft 365 and so on. So you will see that it is very important to figure out what protocol a certain computer is using, because you must give priority in case you're running out of bandwidth to the interactive protocol, such as video sharing, for instance, or audio, and to limit, for instance, a file synchronization through a remote internet drive. And this is the challenge. So how to update our DPI to these changing working conditions. So in essence, what we have done in the past months, we had to quickly enhance our DPI tools that are part of ntopng and part of our toolset to give visibility of this traffic, and also to cheat somehow the protocol infrastructure, because in a way, when we are doing a certain activity such as Microsoft Teams, in essence, the network protocol that is flowing is not the one we expect. Just to give you an idea, Microsoft Teams is using the Teams protocol, so in essence TLS, for connecting with Microsoft for document sharing and so on. But whenever we do video conferencing, the story is a little bit different, because in essence, Teams is using Skype. I don't know if you know that, but Microsoft years ago has acquired Skype and has slowly integrated let's say a successor of the Skype protocol used by the consumer Skype application into the system. So it means that we had to also make let's say complicated enhancement to the software to make sure that the traffic we are reporting is correct. So in this case, people are supposed to see Teams instead of Skype, even though the traffic that is flowing in the network is Skype in practice. And as you can see, this example of traffic taken by on a real network by a computer, you will see that a lot of traffic today is really taken by those video conferencing. And if we compare the various applications, you will see that the bandwidth taken by the application, and therefore the traffic being exchanged, depends strongly on your capabilities. So if you turn on video or not, and on the application itself. And because we are now talking about megabits, so if you have a company, let's say of 40, 50 people, you will see that using 100 megabit or more, it's a simple activity. This in addition to the existing network activities that you had in your network. And because of this, an important part is to bind traffic to users to understand, first of all, who is doing that, and second, with DPI, like I shown you before, to put at work traffic shaping capabilities that can reduce this traffic. I let Alfredo talk about this second part.
Thank you, Luca. Everyone, this is Alfredo. Can you hear me?
Yeah, okay.
Let me share my screen. Okay. Okay, thank you. So we have seen how the impact of the lockdown on the infrastructure. We have seen the impact on the bandwidth utilization, especially with respect to specific protocols like video conferencing protocols. But there is another, let's say, issue that Luca already introduced before, which is the identity management. So we need to understand who is generating traffic inside our network. And with the increasing number of VPNs, this is not really easy. We will see why. In a pure private network, let's say, where ideally all the users are inside our network, it's, let's say, easy to identify who is generating traffic, because hosts are usually easily identifiable by IP address or host name, or in the worst case, the MAC address. So we, in ntopng, when we analyze the traffic, we can go in the host list, sort by throughput, for instance, and we see the IP address which is generating that traffic, and we can go inside the host and check the host details, or ntopng even has the ability to specify an host alias. By specifying an host alias, we're able to see at a glance in the host list who is the user which is generating the traffic, for instance, if we manually specify the user which is using a host. So we have this label just next to the IP address in the host list. Or we can click on the IP address and get the host details, including the MAC address, again, the IP address, the label that we specified, or the host name that ntopng automatically detects. When we have a VPN, this is not that easy, because in a VPN, IP address are dynamically assigned to users. So a remote host or a remote user can have different IP addresses over time, or the same user can connect from multiple hosts. And when we analyze the traffic with ntopng, we see that there is some traffic generated by an IP address, but we don't know who is behind that IP address. In order to figure out who is generating the traffic, we have to go to the VPN concentrator, look at the logs or the leases, and check who is the user which is using that IP address. But then we come back to ntopng, and maybe in the meantime, the user disconnected and connected again, changing the IP address. So we have to go back again in the VPN concentrator, but this is not working. So this is an example, for instance, where we have a user connecting to our network through a VPN with this IP .103, and we don't know who is the user behind this IP. So the idea is, when the user connects to the VPN concentrator should tell ntopng, hey, a new user connected, the username is Mario, and the IP address is .103. In this case, when we analyze the traffic in ntopng, we are able to see that that IP address is tied to the user Mario, so we know who is generating the traffic. And this is possible thanks to the Syslog integration that we implemented in ntopng. In this case, as we can see here, we have that in the host list in ntopng, we have the IP address .103, which is the IP address of the user Mario. And we didn't specify Mario as labeled manually, but ntopng did that for you automatically, talking with the VPN concentrator. Now, let's see how the Syslog integration works. So how the VPN concentrator can talk with ntopng. This is the big picture of the ntopng architecture. So ntopng already is integrated with external tools. Like Luca said before, we are able to export time series to InfluxDB or Elasticsearch. We also use Redis. We use our other technologies like NDPI, which is one of our libraries for the packet inspection. Thanks to this library, we are able to identify the layer 7 application products, for instance. And of course, ntopng has a web interface, web-based interface. We have a RESTful API that you can use to interact with ntopng for getting data, for instance. And we have multiple ways of collecting information, so of acquiring data from different kind of data sources. ntopng can analyze live traffic, so processing packets from a network interface, traffic coming from a tap or a mirror port. Can analyze flows coming from sensors like mprobe or from routers using mprobe as a proxy, or can collect syslog. So we'll focus on this component, so the syslog collection. So ntopng implements a syslog server, which is able to accept connections over TCP or UDP from syslog clients. So one client can be a VPN concentrator or a standard Linux box. Or you can use, in many cases, our customer already have a centralized syslog server for logging logs coming, events coming from all the hosts in the network. So in that case, you can use this syslog server to forward the events to ntopng. If you already have the centralized logging, probably you don't need to log twice the logs, but ntopng can use those events for correlating events to the traffic, to traffic events. In some other cases, you need this syslog proxy. For instance, in case of an intrusion detection system, which is logging logs on the local box, you need this proxy to forward the logs to ntopng that can be on the same machine or on a remote machine. As I said, ntopng is able to collect logs from different data sources like VPN concentrators, intrusion detection systems, or hosts. And this is implemented by different plugins in ntopng. So we have a plugin for Suricata, for instance, a plugin for a Fortinet firewall, a plugin for a SonicWall firewall, and so on and so forth. So you have to configure ntopng for each source IP what kind of client you have. So who is generating the data in order to let ntopng understand how to process the data. If you don't specify the source, ntopng tries to automatically detect the application type based on the application name that is coming with the logs. So in many cases, you don't even need to configure anything in ntopng. So let's see the use cases in details. So the VPN concentrator is one use case. In this case, ntopng is analyzing traffic coming from your mirror, from a spam port, or from a tap interface, for instance, for extracting network metrics and providing network visibility. At the same time, it's collecting logs from VPN concentrators. Today, we support Fortinet, OpenSense, SonicWall, Sophos, OpenVPN, and a few more. This way, ntopng is able to correlate the syslog events, so user Mario with IP 103 connected to the network with the network traffic. The same way, ntopng is able to collect, as I said, information alerts generated by intrusion detection systems in order to correlate threat detection, intrusion detection events with the traffic information that ntopng is extracting from the traffic itself. Also in this case, Suricata, for instance, which is an intrusion detection system, exports information through Syslog to ntopng. This is an example of alerts generated by an intrusion detection system, which are displayed in ntopng. And so ntopng has this alerts menu where you can look for host or flow alerts. You can manage them, or ntopng itself can act as a proxy, let's say. So ntopng is able to export the alerts to external endpoints. I don't know, you can get notification by mail on Slack, or we have the ability to call an HTTP callback. We have many ways of exporting alerts. And in this case, we can see that there is an alert about a Trojan, which is, in this case, an alien spy rat. And we have the flow information. So ntopng in this case is correlating the alert coming from Suricata with the flow that ntopng is extracted from live traffic. So you have here the 5 tuple of the flow with all the client and server information. And you can click on the flow information to get the flow, and you can drill down up to the packet level. If you enable continuous recording in ntopng, you're able to dump the raw packets for the flow, so the pickup, and you can even download the packets that triggered this event. ntopng can also collect logs generated by standard hosts, let's say, in our networks, because most of the hosts of the machines are able to generate syslog. A standard Linux box is generating syslog out of the box. And this is useful especially for machines that we want to monitor, like, I don't know, a web server where we want to log all the access denied events, for instance, or if we have authentication failures in a standard box for SSH, for instance, we want to log them. So we can integrate this with ntopng. In this case, for instance, we have alerts generated by a Linux box, or we have an authentication failure. Also in this case, the log you see is correlated with the IP address of the box. So you can click on the box and look at the traffic over time, or even drill down up to the packet level. So, for instance, we can click on the host, as in this example. We go to the host details, the host page. We can go to the historical chart, select a time interval where the event happened. We can even apply a filter to restrict the traffic that you want to extract, and run the extraction. We get the pickup file matching that traffic. Before wrapping up, I want to show you a live demo to show you a really short demo to show you how what we have seen works in ntopng. Let's start from the bandwidth utilization, for instance. So we want to monitor who is using the bandwidth in our network. For instance, this is a small virtual machine that we're using just for the demo. But this is the traffic generated by the virtual machine itself this morning. And as we can see, we have a traffic spike around 9:30, and we want to see what is it, who is generating the traffic, what protocol. So we can go inside the interface, in the historical chart, we can select the top applications. Here we have the chart with the top applications in this period of time. So we see this traffic spike. We go on the spike, and we see that the protocol is using most of the bandwidth is Ubuntu 1, which is likely the Linux updates. So we can drill down, we can go here. You can see, of course, the top applications. We can see the top servers, for instance. I think this virtual machine is a bit slow. So you can see all the servers and the bytes generated by each one. So in this case, we received from this server more than 100 megabytes. And we can even drill down up to the flows. So here we have all the sessions that generated the traffic in this specific time interval. And maybe I can zoom here. This virtual machine has some issue. Okay. So here we can see that the flow with the highest throughput are from canonical.com, which is the Linux updates, the Ubuntu updates. Now, what I want to show you also is the VPN integration. So in order to enable the VPN integration, in order to correlate the traffic with the users who generated the traffic, we have to, first of all, you have to configure ntopng, but this is something that usually if you're buying a box, this is already pre-configured. So here we configure the syslog interface where specify you want to listen for syslog events on a specific port, both UDP and TCP. And if you have to use, I don't know, for instance, if you have already your syslog server, you can configure the syslog server to forward the logs to ntopng. And you can do this creating this. For instance, if you're using syslog, you can create a simple configuration where you specify I want to forward the logs to the box running ntopng on this port. And of course, you have to restart the service. And at this point, ntopng is receiving the logs from syslog. Now, what you have to do is to go to this new syslog interface. This machine is not really responsive. I don't know if it's a connection issue. No, I think it's the CPU of this virtual machine. You can go in this page inside the syslog interface under the syslog log producer configuration, and you can specify that if you receive logs from this producer IP, this is a Fortinet log. So this is a VPN concentrator, and we have to parse the logs using the Fortinet format. So at this point, ntopng is receiving the logs, is inspecting the logs, is parsing them, extracting information like the user that logged inside our VPN, and we are able to correlate the user with the traffic. So let me show you an example. If we go on this interface, I think I selected the wrong interface. If we go to this interface under the hosts, so these are the flows generated inside our network, and this is the list of hosts. Let me enlarge a bit. For instance, I simulated connection from my user. Just a second. Let me see, a new host should appear here. Let me see. Oh, I'm still on the wrong interface. Sorry. So what I'm doing now I'm simulating a connection of a user in our network. And I want to show you that the traffic generated by this user is tied to the username. I don't know why. Okay, so this is the user, Mario, which connected to our VPN now. You see it's seen since 1 minute. And the user is generating some traffic using this IP address. So now we are able to go, for instance, inside the host and see the traffic that this host generated over time, or we can look at the flows that this host generated over time. So we are running out of time, so this wanted to be just a short demo to show you how to do what we are seeing inside the presentation with ntopng using the really basic features of ntopng. Let me come back to the slides. Luca, do you want to wrap up, or do you want me to do that?
Okay, you can do it.
Okay, so we're seeing now this lockdown had an impact on the infrastructure. We've seen how we improved our tools, both ntopng and NTPI, to help you finding who is using the bandwidth with more granularity, because we had improved the support for the video conferencing protocols to check who is consuming the bandwidth, and also the user who is consuming the bandwidth with the VPN integration. As I said, today we are able to identify traffic, user traffic generated when using VPNs, like including SonicWall, Fortinet, Sophos, OpenVPN, OpenSense, and more. We are using the same Syslog integration also to collect information from IDS systems like Suricata for security alerts, and also from the hosts. Also wanted to mention that we are changing a little bit the argument. I want to talk a little bit also about the performance. ntopng is able to process more than 100,000 flows per second, and we are able to process with our sensors traffic up to 100 gigabit. At the moment, we are able to process at 100 gigabit using FPGA adapters, but we are working on new commodity adapters. For instance, there is a new adapter from Intel, which is the E810, which is not yet out, I guess, on the market, but it will be soon. And we are working on accelerated drivers, and we are currently testing them, and it seems it's really fast. So the idea is to use commodity adapters for processing traffic at 100 gigabit, in addition to the FPGA adapters that we are using today, which are more expensive. That for some use cases are mandatory, but for other use cases, like net flow generation with ntopng are enough. I mean, using a commodity adapter should be enough with the new adapters coming from Intel and our accelerated drivers. Our open source software is on GitHub. We have a Discord channel and a Telegram channel if you need help, if you want to contribute with ideas, if you want, I don't know, if you want to join the community. We have, I don't know if you want to talk about the new events that are coming, Luca.
Yes, tomorrow, 4 p.m. in the afternoon, we'll have a community meeting on Discord. You can find the link here, so ntop.org/community. In a way, we want to meet periodically our users and to understand, first of all, what is not working for them, to support them, but also to understand the direction that we want to take. Unfortunately, we cannot do physical meetings at the moment because of the global restriction on travel. So this is our way of doing that. So this will be an informal meeting. And next week, instead, on Friday, we'll be talking about how to extend the ntopng with user plugin. The plugin are very important because allow you to generate alerts or interpret data in a simple way, so that without being a developer of the ntopng kernel. In this case, we'll be talking about network security, and in particular, the idea is to talk about cybersecurity and IoT. So this is the upcoming webinar in a week. If you have questions, so we are here to answer.
Luca, can you hear me? There was a question in the chat if the checkpoint integration is supported.
Alfred, I don't know if you want to talk about that.
I guess you mean
Syslog, right?
I guess you mean about the Syslog. No, not at the moment. But I mean, we are open to support new VPN concentrators. We can. I mean, if you open a feature request on GitHub, or even better, if you send us a Syslog log generated by those appliances, that will speed up the integration.
Okay, thanks. So for Jenna, Luca and Alfredo, thanks for your speech and your overview. It was quite interesting. So for the audience, I hope you get a better feeling what you can achieve with the Ntop technology itself, and which kind of possibilities around the NetEye ecosystem is possible to achieve. For example, for the checkpoint integration, as we in wuerth-phoenix itself are using checkpoint as firewall, I can tell you that checkpoint inside Elasticsearch can be processed, and obviously the NetFlow and network data and the Ntop data, which are processed by Ntop itself, can also be shipped to the Elasticsearch stack inside NetEye, so we can correlate all those information and create, or you can get a SIEM overview about that. In the chat, I put also the link to the survey of this webinar, so I will do it again. So if I kindly ask the audience if you can give us a feedback about the event today, and use the link to send us your opinion and feedback. So thanks for that. We will be still stay online a few minutes. So if there are questions which you would like to discuss, to share, please write them in the chat, and we are still available for a few minutes to answer your question.